Welcome everyone. Thank you for joining us for today's webinar. I am Saukartika from TSI and I would be the moderator for this session. Today we are presenting DFDL and the presenter is Mr. Ed Jordan. Just a little housekeeping before we get started. If you have any questions during the session, please click on the hand raise button so that you'll be unmuted to proceed with your questions, or you can enter your question in the chat box. Without further ado, we will turn the time over to Mr. Ed Jordan, presenter today. He is a director software developer who have been associated with TSI for over 20 years, and his fortes are TPF, C, and assemblers. Ed, you can proceed with your webinar now. Thank you.
Thank you, Saukartika. Hello, and I'm Ed, and today's webinar is about DFDL support in zTPFGI. It will be mostly a demo, but we have a few PowerPoint slides that we'll look at as well. So to start with, what is DFDL? DFDL is a language for describing data formats. It's an extension of XML schema, so this description of data formats is written in XML. And more specifically, it has an XSD format extension. And what this description allows is conversion of data from a native format to an XML information set. Just to go into a little more detail about that, suppose you have a C, C++ struct, or you have a TPFDF database file, and these have certain formats. There's certain fields, they're in a certain order. Some fields are integers, some fields are text. Sometimes you know that it represents, a certain field represents a number, but it's written as text. Sometimes it represents a number and it's in binary format. Sometimes the field is actually the length of the next field or a later field, or sometimes the value of a field determines that a later substructure shows up or doesn't. You know, for example, the LREC key is 80, so necessarily certain other fields follow because of that. And there's other things that would describe your data, such as what is the format of the integers? Is it big endian or little endian? Does the most significant byte come first in an integer or last? And is the text an EBCDIC or ASCII or something else? You know, so there's all these ways the data needs to be described to really understand it, including the offsets of the fields, if they have certain hard-coded offsets, or maybe they're just as long as they need to be and one follows another. Sometimes there are certain delimiters in the data, like a comma and a comma-separated values file. So all these things are things that DFDL can describe. Once that description is correct, then it can, for example, take a block of data that's in the format described by one of your C structs, and it can convert that to a different format. Or it can take a TPFDF file, data in that format, and convert it. And the conversion is really a two-step process. First, the data goes from that native format to another XML file, an XML document that's called an info set. And that document has just the same data, only it's written out in XML with XML tags and so forth. Then that XML info set, which is also in the application called a logical instance sometimes, that can be converted back to even a different native format. So for example, we could start with TPFDF, and as long as we have the right schema, and the DFDL schema is correct, it can be converted to XML, and then that XML could be converted to JSON or BSON, binary JSON, or other formats. And you can see how that would allow data interchange between zTPF and other systems. In fact, that's why it's a key piece in implementing the IBM recommended solutions for data interchange. MongoDB is a zTPF can have a MongoDB server that allows data to be queried through no SQL, no SQL. I'm not real familiar with it, but somehow queries can be made on the data, and the data could go back, and it could be written or read if you allow that. Once that the schema is known. The schema is also used in business eventing, and it's used in creating APIs for RESTful access to TPF data. So, the DFDL is like the key piece at the base that that enables these other technologies. So in zTPFGI, we could divide the features that support DFDL into 4 main categories: to generating the schemas from your data formats, editing those DFDL schemas so that they're really correct, testing to make sure that they're really correct, and loading. And today's webinar will demo the first 3. We won't do the last one. Now let me see. So I won't spend much time on this slide, but this is simply saying that schemas can be generated from TPFDF or from header files. And in both cases, then the resulting files are put into your project. Okay, so let's handle generation first. So here is, here is zTPFGI. And first, let's show how to generate a schema from a header file. So I have a project in my projects view. The project has an includes folder that has the header files in my project, and I also have a DFDL folder in my project that contains schemas that I've generated already. And so when a schema is generated for this for a header file in this project, it's put down here in this folder. So I'm going to generate schemas from this particular header file. This header file has a couple of structs. One is, let's see, one is db timestamp _s, another is line iota _s, and you can see they have certain fields in the structure, and this can be described by DFDL. So to generate the schema, we would right-click on the header file and select Generate DFDL Schema. Now we're going to get some messages in the output, and at the end, if there were any errors, it would tell us. Generally, there would be errors if you can't compile, correctly compile a program in your project. You probably can't correctly generate a schema either, because it depends on some of the same. Make TPF is called. It depends on some of the same basic supporting system, but you can see it did work for us, and 2 schemas were generated from this header file. One db timestamp _s.gen.dfdl.xsd and line iota _s, and DFDL schemas end in dfdl.xsd. So we can open these, and we will come back and open one or both of them in a minute, but I want to go ahead and show you how to generate schemas from TPFDF before we do that. Now, we have already connected to a system. For generating schemas from header files, you don't have to connect to a system. But for generating from TPFDF database files, you do. So we're connected to a system. So on the System tab, there's a new button called New DFDL Schema. I'll click that, and this this shows us all the databases available on the system, you would have more than we do. We just have a test system, and you can filter these according to whatever you type. It will filter that for you. You can also specify the target project where you want your schema to be placed. And actually, I do want to generate it on this other project. You wouldn't have to do this. You could just go ahead right from where we were, but I want to make it clear. So here's the schemas I have generated right now in this project. I'll go back to this list, and we'll just generate it from, let's see, do this one. And that's the right project, so I'll say OK. Now we'll get some messages in the output view that tell us what's happening. The processing is completed. And as you can see, we did GR27SR, and that schema has been created down here, and the project has been refreshed. So that's really all there is to generating, and I think we can move on to editing now and talk about how that works. So to edit the schema file, I said I would come down and open one of these in this other project, so I will. Let's open this one, DB timestamp. So when you double click a DFDL schema, a new editor opens. A couple of things happen. The new editor opens with the schema information inside of it, with the schema, and then also a new layout opens, and the layout has a certain ribbon added, and it has certain other views, supporting views also added to support the DFDL editing and testing. So okay, so this is the what we call the grid view of the schema. The editor has 3 tabs: grid, source, and test. Test is used for testing, so we'll talk about that later. But the grid view shows certain important columns, certain important attributes that you can change, and it shows and then you know, you can come in and you can change these values, and most importantly, you can add sample values, but we'll talk about that in a minute. Before we get to talking more specifically about that, you notice that an error popped up down here, and this is saying on line 33, this was a freshly generated schema, but you'll often have errors in freshly generated schemas because they don't generate perfectly, and it says property length is not defined. And this is occurring in the error tab. So if we double click there, that takes us to, well, it was already showing, so it wasn't very dramatic, but that takes us to the field with the problem. And you can see that over here in the properties view, which stays in sync with the editor, active editor, the same error is occurring here. It's marked with an icon, and we could come here and we could set the length, and then this error message comes from the DFDL parser serializer that's distributed with zTPFGI, that's on the client machine. And so when we open a schema, to validate it, we run it through the parser serializer. And anytime then after you make a change and you save your schema, we run it through and validate it again and show the errors down here. So I won't worry about exactly the right value to put for length here. I'll just put a value, and I'll hit enter, and I'll save. So I'm hitting Control S right now, or you could quick save up there. So I hit Control S. So now we're going to run it through the validation again, and you can see the error went away. So that doesn't mean 50 is the right value. It just means that we're no longer violating the rules of the schema. that said that the length had to be specified. So that's an example of correcting errors. Other types of, there's many other types of editing that you can do here. You can, for example, move fields around. Maybe they're not in the right order. So you can right click and say move down, and you see months move down. Or there are keyboard shortcuts for that, control up and control down. So if I do control down, you can see month is moving down, and control up and it's moving up, and so like that. All of these edits that you do to the schema are undoable and redoable. So I've got the undo button, or you could hit Control Z. You can see as I click the undo button, month is moving back through all the steps that I made it go through when I moved it around, or redo will move it, you know, and redo those changes. Before I forget, I want to talk about the Source tab. The Source tab shows the source of the schema, as you would expect. So it shows the actual XML, and you can word wrap it if you want to, or you can take off word wrap if that's clearer to you. And what is selected in the Source tab it also, if possible, stays in sync with the grid when you switch back and forth. So if I here's something called -1, so we'll put the cursor there and we switch back to the grid. -1 should be highlighted. Yes, it is. Okay, that's good. And and if I do -2 and go back here, -2 is highlighted. If you make a change, you can, if you want to, edit the text here and then switch back to the grid. And sometimes you might, most of the time I think you wouldn't, but there might be a situation where you would want to. If you're changing the XML and you make a mistake, for example, you produce invalid XML, like say this is an obvious one, but I'm changing the closing tag and now it's not going to be valid. If I switch back to the grid, you'll be told there's an error in the XML and what line it's on, and you'll be able to either discard your changes or you know, return and fix the error. I'll just fix that and then go back, and now everything's okay. Okay, so we were talking about different ways you can change the schema. We've talked about changing field values, and we've shown moving values around. You can also add more fields. This sequence is like sort of like a structure with fields in a certain order. They have to, but you can add another field called a local element. So there's the field here. Once you've got it on there, you can change the name, you can change the type, and then you can, if it's not in the place where you want it, you can move it up to where it should be. This schema didn't generate with any complex types. We should probably open one that did, but a complex type is it's like a struct type that then your global elements might use. Well, actually, DFDL schemas are too complicated to go into all the details and actually right now, but it's a pretty capable format. It's actually a subset of XML schemas. You can't do everything. You can do more things than you could. It's an extension, and also it's a subset. So anyway, we'll leave that aside. So there's the schema. Let me open. You can open multiple schemas at the same time. So here's this one that we generated from TPFDF. I'll open that. And when you open that, you see properties now is keying off of this editor. But if I go back here, properties is keying off of my original that was open. Another concept we have is that of a primary root element, which is the root element we are validating and validating and mainly testing. So this has two global elements, and you can switch between which one you're primarily validating and testing by by changing that. And you can see as soon as we switch to this other element, we validated it and we found an error in it. But when we switch to prefix LREC, it validates it again, but there is no error in prefix LREC. Okay, so the ribbon tab shows many other things you can do, and ways that you can change the schema. Adding another global element. You can add a complex type, and then change it. And once you have a complex type, you could add a global element that has that type. So it's sort of like writing C code or C++ code. You create a class, and then you create an instance of that class, sort of. Or that's a little bit like what it is. There's simple types and definition formats and escape schemes and all these things that are important to DFDL, but not all of them are used a lot in the DFDL schemas, but several of them are. So we've talked about the editing. Now, one important use of the editor is to, and now we'll sort of transition into talking about testing the schema, is to put in sample values into the fields so that you can create one of those information sets that we talked about. So basically, one way to test the schema is to give sample values to the important fields, create an XML document called a logical instance or info set from those sample values, and then see if the schema, see if it's correct, and see if the schema can parse and serialize that data. That's basically the testing that you go through in zTPFGI. So to add sample values, you would find fields that need sample values, and you would, based on your knowledge of the original format, you would know what kind of sample values to put in, and so you would go through and you would identify all the important places where the sample values should be, and you would put in the correct values. And I'm just typing random values right now, except I know that this should be 80 because this 80 determines which choice is here. And that reminds me of one more thing that I should talk about in the editor, which is the DFDL DFDL expression editor. So for certain fields, certain attributes can have DFDL expressions, which is almost, it's in the XPath languages, it's almost like a little coded statement telling the schema how to behave. So you could say the value of this, you could say the value of this field should be the value of another field, but modified in some way. And that's the kind of thing that a DFDL expression can do. So let's see, to do a DFDL expression, you would have to find, I can't remember, okay, you would find a field that can be changed by DFDL expression. You would right-click it and say XPath expression dialog. Then we have the XPath expression dialog sort of wizard, and this would allow you to create a DFDL expression to fit there. So DFDL expressions, these are the fields that would be available, and if you want, you can drag and drop them down so you don't have to know how to reference that field. It would be put in there for you, and then you could do certain things to the field based on whatever purpose you're doing in the expression. So it also has, there's functions you can use inside of the expression dialog. So and you can do that, and you can say in type ABCD contains ABC or whatever. So anyway, you can see that it's like a little programming language where you can say, for this value, I want you to go through this process and programmatically create the value for this field. I'm not okay. And there's also in this dialog box there is autocomplete. So if you didn't want to go through here and look in the categories and find the right function you want to use, you could say just start typing and then hit Control Space, and then it shows you all of them, and then you can keep typing until you find the one that you want, and you can put that in. So that's the expression editor. Okay, so now we were talking about adding sample values, and so I've been showing you how to add sample values, and once you add sample values, then you would hit the create logical instance and start to test. And so we'll talk about testing now. And to do this, I've got one that I've already carefully put in values that work. So I'm going to open that schema that I've already done that to. Okay, so no, I don't need to save that. So here's a schema that was generated from TPFDF, and prefixed LREC is the primary root element, and you can see I put in sample values here, and mainly I've just put in random, but I did make sure that I put in a correct link, the link that works, and I put in the correct LREC key for this element. And so this element would be used then, if I click create logical instance, this element would be used to create the logical instance, which is the XML example of this of the data here. So we'll go ahead and do that, and this starts shading into the testing. So I've created the logical instance, and it's appeared over here in the DFDL instance view. See, this is tabbed with the properties view, but this has come forward. So this has two panels, two tabs. One shows the XML in a browser window. The other shows it in a tree view. And so you can see, yes, I generated this. Yes, I got the data that I thought I was going to get. So far, so good. Now, now that we've got the logical instance, now we can move on to test parsing and serializing this. So I'm going to right-click that and say launch test. Now what happened here is that we actually opened another type of editor, a test editor. So here, this is the DFDL schema that we were working with, this editor. This is related to it, but this is one test for it. And so this test happens to be testing that logical instance that we produced. And this, you can see that here on the left where it says input, that's the same data that was in the logical instance. And so this is an example of the info set that we were talking about. Now to test the schema, we would like to serialize this, and that means put it back into native format. So just click that button So we go out to the parser serializer and ask it to serialize using our schema, and it did. So now we can look here and see, does this look correct? I mean, you'll be familiar probably with if you were doing a DF file, database file, you'd be familiar with how the data is supposed to look. Does this look like a valid record for that? Are the offsets right? Are the values what I put in? And they do seem to be. I see a lot of 6s. I see a 5. And I see the 80. So that's all looking good. So that looks good. So that's one question, is can it be correctly serialized? The other question is, can it be correctly parsed? That is, can we take this data and put it back into an XML info set? So, and that's easy to do. You just click the next button, which is we kind of call it reverse test. So now we're taking that block of data. We went back out to the parser serializer, and we asked it to create an XML info set out of it. This info set we created, our zTPFGI created. This info set was actually created by the parser serializer. And you can see that the data is the same. There's no important differences. This XML line was added, and it's not over here, but that won't make a difference. That's fine. You can see a few attributes were left off by the parser serializer. That's also fine. That doesn't matter. But comparing the order of the fields, the data, the types of the data, and everything, the order of the fields and the data, we can see that it looks correct, and that's good. If it was a longer example and you wanted to actually do a more formal comparison, you can right-click and say compare input with reverse test. Once you do that, we create a couple of temporary files so that we can compare them, and you can choose to either use our internal comparison in zTPFGI or an external compare tool. I've got it set up to use an external compare tool right now. And when we run that, I'm using WinMerge, which is a free and good tool for comparison. And, so you could look for, if you find this easier to look in, because now they will scroll together and things like that. So you might find it valuable to do that. I'll just close that and close a couple of temporary files that we created. Now, another thing you can do is you can actually come over here and edit this logical instance right in place right here. If you say you want to try it, you've noticed an error and you don't want to go back to the schema right away, or you want to try out something different, you want to try a different value or something, you can come in here and type and change the value, and then run the test again. And we'll go back out to the parser serializer, and you see a 7 appeared here, so it got that data. If you say you make some changes here and you don't want to lose them, because you say, well, I've really created a good example here, I'd like to be able to run it later, a good test, you can right-click and say Save Input As. Then we will pop up a way for you to save it to your local machine so that you can run it later. I will just give it a name and save it. A second. Okay, so so we've saved that. Now I want to show. All right. I want to show the what happened. So we created the test. Now, how do you access the test again easily later? So actually, what we do is on the test tab, which I said I would come back to, you see that new input XML3 has actually appeared here, so that we can we can open it easily. I'm going to close that test. You can have multiple tests open at the same time. It's okay, but I'm just going to close that for clarity. And now if I double click here, I get that test data opened back up. And so this remembers the this test tab remembers the test that you're using to test, so that you won't lose your test. You can run them again later after you make some changes if you want to. You can also then create a new test, delete a test, and so forth. You might create a test by dragging and dropping here, and actually I'll do this. Let me delete a couple of these because I want to show you the other way of testing. Because right now we've been talking about testing, starting with XML info set and serializing it. But you can also start with the native data and parse it in the test editor. So I want to show that. So we'll create a new test, and you see we're going to do parse as the test. And we're going to go to PC files, and we're going to find here's some data that I've created before. This is a block of native data that I would like to run through the serializer. So I'll drag this over, drop it here. The root that we want to test is not indexed, it's prefix delrec. And we want to parse as our primary test. So I'll say OK. And now we've created the test here, and to run it we can double click. So now we've got the native on the left and the XML on the right, and the reverse test is going back to the native format. So we would run this, and there it's created the DFDL has created the info set, and we can reverse test that. And then we can compare and say, well, did I get the same thing? Is this DFDL really working correctly? Okay, so that's the testing. There are a few other things you can do. You can, if you find it useful, you can, because some of your clients may be using JSON, and you want to see how this will look to them in JSON. You can convert XML to JSON, and there's the JSON version of the info set that we were looking at, and you can save that if you want to. Other things you can do is in your native data, you can make the buffer bigger, smaller, trim it, and do find replace and things like that. You can do find replace here also. Okay, so that is I think that covers the major parts of the testing. So we've covered generate, we've covered edit, and we've covered test. Then once you're satisfied, you would load, but I'm not going to show that. And I think let me go back to the PowerPoint and see if we forgot anything. There's the editing, and the properties view, and the output view where you can double click, and the testing, and logical instance, and the test editor. Okay, so I think we've covered everything. So if there are any questions, I'd be happy to try to answer them if I can.
And there was a question from Thiru, and the question is, if we assume that the GR27XS record is for flight records, is there a quick way to change to be a flight record without changing each field?
No, I don't know of one, and I don't know enough probably about the business domain to really be able to answer that very intelligently. But as far as I know, in DFDL, you would just need to you could move the fields around, or maybe using a different LREC key would help.
I want to change the name GR27 to flight name.
Oh, can you change the name? I think that's not a good idea to change the name. I guess you could change the name if you wanted to. Yeah, I guess you could change the name. You could do a save as and change the name if you'd like.
Okay. And he continues the question with meaningful to Java developer, that is why.
Yeah, right. Yeah, I know that often the DFDL is being generated from C headers rather than TPFDF, and in that case, the developers are careful with the names that they set for their headers so that it makes sense to people looking at them. I mean, to their structs. I mean, I don't know all the ins and outs or what would be. I think that yeah. Yes, I wouldn't necessarily change the name of the DF though, because you have to load that, and then zTPF has to be able to know which database to go to. So I'm not sure about all that. Somebody who knows more could answer that.
He also continues his question like there was a find and replace. Can we use that?
You can use find and replace on the text editor. Yes, you can do find and replace. So if I go to the source, is what I'm saying. If I go to the source tab, there's a find and replace, and there's find and find and replace. You can find and replace here.
If you have any questions, please click on the hand raise button so that you'll be unmuted to proceed with your question, or you can enter your question in the chat box. There's a question that is there any plans for an advanced webinar or session like this? So this because this was a lot of info.
Yes, it was. It was a lot of info, and we could for example, just to do a webinar on editing would be valuable, or just on testing. I think that's a good idea.
George Moose, yes, this session has been recorded and we'll send you a follow-up email. No worries if you entered a bit late. A gentle reminder to the attendees, if you have any questions, please click on the hand raise button so that you'll be unmuted to proceed with your question, or you can enter your question in the chat box. Okay, there's a question from Zari Bari, and I have unmuted you, Zahari. You can proceed with your question.
Yeah, I saw the adbi.xml file. Okay, what is that one? Is it for? Is it for MongoDB?
Can someone help me answer that question? Is Shankar on the call, on the meeting? Or maybe Jeff?
Is it generated also by this zTPFGI DFDL tool?
It is generated by the same process that generates the schema, and to generate from TPFDF. So when we what is it that we run? But we run an IBM command to generate the schema from TPFDF, and it generates both of those files. And I'm sorry, I don't know exactly what it does, but we don't throw it away. I think if any TSI people want to answer, they can.
Sorry, Jeff and Shankar is not in the call.
Okay.
Yeah, you can answer that later. It's not necessary because you were talking about the DFDL for okay, for
Yeah.
schema here. Yeah, it's all right.
Okay, thank you.
Welcome.
Ed, it looks like we have answered all the questions, so we'll wind up the session. Thank you, Ed. Thank you, everyone. We appreciate you being here. A short survey will open up. You can specify topics for the upcoming webinar session. We will send you webinar follow-up email within a week's time, which will contain the link of this recorded session. If in case of any queries, contact customer support executive or write to productsinfo@tpfsoftware.com. Thanks again for joining us today, and we have webinars followed on second Wednesday of every month. We'll see you next time. Bye. Thank you.